Welcome to my class on steady state heat transfer. In the previous class, we have formulated the expression for steady state heat transfer through a composite wall. In this class, I will introduce the concept of contact resistance between layers of the wall. Now let us see what is a contact resistance. When two layers, when they are coming in contact, so most of the time these two layers will not be making perfect contact due to surface irregularities. If you magnify and see, you can see the surface irregularities, and the contact will happen only in certain points. It will not make perfect contact, and only some points it's making contact, and between these gaps air or any other fluid might be present, and this will impose resistance to the heat flow. So this is stagnant fluid layer. The heat has to be conducted through this stagnant fluid layer and then conducted through the second layer. So this will impose some resistance to heat flow, and suddenly at this very small gap, it is a microscopic level, the gap is very small, and in that small gap there will be a sudden temperature drop due to the contact resistance. So the resistance offered by this at the interface due to the imperfect contact and due to the gases present in that gap, the resistance offered is known as contact resistance. So resistance offered at the interface due to these irregularities is known as contact resistance, and its unit is meter square Kelvin per watt. For unit area, generally they will give for unit area so much meter square Kelvin per watt. So that is the resistance per unit area. So the unit meter square Kelvin per watt indicates that it is for unit area. If you have to find out for a 5 meter square area, you have to divide by 5 to get the total resistance. When the area increases, the resistance will decrease. So generally they give for unit area, and if area is more for the heat flow, then you have to divide by the area to get the total resistance. So if I represent RC as the contact resistance, RC divided by area will give the total contact resistance. RC is the contact resistance per unit area, and that divided by area will give the total resistance to the heat flow. Now as a result of this resistance, temperature will suddenly drop at this interface. So suppose that temperature, if you take here T1, here generally at the interface we will take it as T2, only one temperature we will take. Now let us take it as T2 dash and T2 double dash, that is two temperatures we will take. So I will represent it generally by T2, but T2 dash and T2 double dash. So there is a drop in temperature. So temperature will go like this. T1, it drops in the as it conduct through the first layer, and so you get T2 dash, and then it drops to T2 double dash, and then to T3. And if a convection is involved, that also will offer resistance in the heat flow path. So if a contact resistance is given between any two layers, then to find out the total contact resistance, that resistance given per unit area divided by area will give the resistance for the heat flow. So you should add this resistance to the total resistance. So RC, if RC is the contact resistance, RC by A should be added with the total resistance. Now in this case, if convection is involved, here convection resistance will be there on inside and outside. So let us take that convection resistance, conduction resistance, contact resistance, and again conduction resistance, and convection resistance outside. Now how many resistance are involved? 1, 2, 3, 4, 5. So these contact resistance also I convert. So the temperature difference, fluid inside fluid temperature minus outside fluid temperature divided by summation of all these 5 resistances will give the heat transfer. So Q you can find out as Ti minus T naught divided by 1 by HIA plus L1 by AK1. This is convection resistance, and it's a first layer conduction resistance. Now contact resistance has come between these two layers, plus resistance of the second layer, plus outside convection resistance. So that will give the rate of heat transfer. So you can represent the thermal circuit for that. Ti and T0 inside and outside temperatures, all the resistance. Only thing is that there is another resistance has come in between, that is Rc by a contact resistance. So the temperature and that interface is T2 dash and T2 double dash. Okay, otherwise it's all same, only contact resistance has to be added in the heat flow path. Thank you for watching.